Hi, sixth grade. This is going to be our first video for our last, we'll call it chapter, of the school year for new material. So even if we were in the classroom together, we would be approaching these last two, topic 10 and topic 12 like this. We are going to be combining them together, and we're actually going to be skipping chapter 10, lessons 1, 2, and 3 completely. We already did lesson 4 when we completed topic 11. That lesson had to do with angle relationships, so we decided as a math department for the district to do some rearranging. So that's why 10.4 was lumped into 11.8, and then we decided to put the remainder of chapter 10 and chapter 12 together. These chapters are still going to be dealing with geometry, but instead of transformations and angle relationships, it's going to be dealing more with formulas for measure, such as circumference, area, volume, and surface area. I do have a note up here. I'm going to go ahead and say it now. We're going to be keeping 2 decimal places when rounding answers, which is the hundredths place value. Unless, of course, the directions state specifically how they want you to write the answer. We're going to be looking at a couple different ways today in notes. The reason why we have rounding in the beginning here, the reason why we're addressing the rounding piece from the beginning is anytime you're dealing with measures and properties of circles, you're going to have a very famous irrational number involved, which some of you might already know, and we're going to talk about here in a moment. So a couple of definitions and properties of circles. First, we have a radius. Okay, so if we have our circle here and use your imagination, it's a perfect circle. There's a fixed point in the middle. That's called the center. Okay, that's going to be in the exact middle of the circle. The radius is going to be the distance from the center to the outer edge. And you can draw that anywhere in the circle as long as it goes from the center to the outer edge. Okay, we use r to notate radius, the variable r. Okay, and then diameter is going to be the distance across the circle through the center. So it has to go through that center point, and it has to go extending all the way to the outer edges. We use a D for diameter whenever we're dealing with formulas. And notice here, you'll notice that radius and diameter have some relationships here. So your radius is half of your diameter. So we could have even just said this is your radius right here. Okay, or you can think of it as 2 of your radius equals your diameter, or your diameter is twice your radius. So there's many ways that you can break that apart. But that is going to come into play with our circumference. So circumference is the distance around a circle. It's the same exact idea as perimeter with a polygon, but just to specify for you, a polygon is any 2-dimensional shape that has straight edges and corners or vertices. Circumference only deals with circles. Circles are not polygons because they're an entirely rounded shape. Any figure that has a rounded shape is not considered a polygon. Okay, so then that mini lesson is over, and back to our formula. Our formula here, you'll see written in 2 different ways. And the reason for that is because of the connection we made up here. C equals pi d. This means your circumference, which will always be a capital C, equals the pi symbol, which we'll talk about here in a second, times diameter. But we also said that diameter is the same thing as 2 measures of your radius. So we could also think of it as their circumference equals 2 pi r, or twice of pi times your radius. Right, and then again, I explained it here. That's because D and 2r are the same value. Okay, so pi, here's why we have rounding issues. Pi is a very famous irrational number that many of you I know already have memorized, and some of you even like to memorize as many digits as you can. But you cannot memorize this number completely because it is irrational, which means it does not terminate ever, and it doesn't have any repeating patterns. Okay, so this I like to include because it's a nice connection back to why the circumference formula even exists. Pi is an irrational number that is the ratio of the circumference of a circle to its diameter. So if we set this as a fraction, circumference over diameter, obviously with some rounding issues, it might not end up being perfect, but anytime you take the circumference of a circle and divide it by its diameter, you get pi. Okay, and if you think about it real quick, if we take this variable d and we use the inverse operation and multiply it to the other side, we get pi times d, equals C, which is our circumference formula. Okay, so I think that's a pretty cool relationship there, just to understand why pi exists, why circumference exists. It's not just formulas and numbers people made up. They actually have relationships. The notation is the pi symbol, and then here's the first few digits of pi, but it's often in pre-algebra rounded to 3.14. After this year, I will not allow you to round 3.14. You have to wait and round your final answer. So throughout notes, I'm actually including the exact pi in my calculation and then rounding in the end. And then I'll use 3.14 and show you the difference between the answers. There's a pi button on your calculator. If the book tells you to use 3.14, obviously you should use it, but I'm telling you as your teacher for the next several years, or next few years, I guess, if you would rather use the pi button and round in the end, that's what you're gonna have to do later anyways, so you're welcome to use that instead. And then I have another note here before we jump into our examples. Circumference can be used to describe one revolution of a wheel related to linear distance. Now this is an application that pops up quite often with circumference, so that's why I wanted to take time to kind of explain what that sentence means. One revolution of a wheel means one spin of a tire, like if you're riding a bike. So one spin of that tire wheel would be one revolution. If you picture that tire leaving a track, so if you start on a dirt path and you move forward just so that that tire moves one full spin or one full revolution, it's going to leave a line as its track on the dirt path. And if you're asked to find how far or how the distance of that one revolution is, you can use that line that it leaves to measure, or it's just the circumference. So we're actually going to be doing an example like that together just to give you a little bit better of an idea. But that's what that means whenever it's asking for linear distance using circumference. No, circumference is not a line, but it can leave a path that is a line. So, okay, let's jump into some examples here. This is from the Try It on page 594, which I have right there. Nice little visual for you. So it wants us to find the circumference of the rim of a basketball hoop with a radius of 9 inches. So we've got our full circle here. We want to find the distance around the rim of the basketball hoop, and they tell us the radius. So with our two ways of writing the formula, we know that we need diameter, but that's just the same thing as twice the radius. So I'm going to go ahead and use this second form of the formula and plug in R is 9. So 9 times 2 is 18. So I simplified it here. So there's 3 ways that you can write your answer. If it says leave your answer in terms of pi, you're just going to box in 18 pi inches. Okay, so that's going to pop up a little bit. If it is wanting you to use 3.14, remember I told you I'm okay if you go ahead and use the pi button instead. So depending on your calculator, your pi button is going to be in different places. If you're using an online calculator, make sure it's a scientific calculator so that the pi button shows. If you actually hit 18 pi with the pi button, you're going to need to round. And we're going to keep at least 2 decimal places. So I'm going to, so in my calculator, this is a graphing calculator, so mine's going to look a little more complex. 18 pi equals, so this number goes on forever. So we're going to round to 2 decimal places, so it'd be about 56.5. Oh no, my rounding issue, 55. There we go. Okay. For, if we use 3.14, 18 times 3.14 is 56.52. So notice, even though we kept 2 decimal places in our start, we're 3 decimal places off in our final answer. But for pre-algebra, that's okay. We're okay with that. All right. So that's what this note along the side here says. I will accept either the pi button or 3.14 in your final answers. And again, if it says in terms of pi, which we'll do an example of here in a moment, you would just actually leave the pi symbol, so it'd be even less work. Okay. All right, let's move on to our second example. This is from the Try It down here. There's a better drawing for you rather than the one I drew. Mine's a little slanted. So the circle here has a circumference of 9.42 units. So on this one, they're actually giving us the distance around the circle. We want to find the area of the square. So you might be thinking, well, what in the world does the circle have to do with the square? This one's actually telling us to use 3.14. Okay, so I'm going to go ahead and do that for this problem. But if you wanted to use the pi button, you can. Your decimals just might be a little off, but I would accept it. Okay, so 3.14, the area of the square. Okay, so let's break this apart. If I'm looking at my square, I'm noticing that the side lengths of my squares, because squares, all the side lengths are going to be equal. The side length here is my radius of my circle. Same here. So my ultimate goal is to find the area of the square, which I would need the side length. Well, the side length is the radius of the circle. So we want to start by finding the radius of the circle. Okay, so that's what this little paragraph says here. So we're going to work backwards. If we use, we're going to pick this formula again, since we are given radius and not diameter. And we know the circumference is 9.42. So we're going to plug that in for C. Okay, 2 times pi times the radius equals 9.42. Well, 2 pi is just a number. So just like solving an equation, we want to get r by itself. We can divide 2 pi to the other side. Okay, now I took this in a couple different steps here. You might be able to take all 3 of these steps into one. 2 pi, or 2 times 3.14, is 6.28. Hold on just a second. Buddy. Sorry about that. He got stuck between his toys. Okay, so to finish up this problem, these 3 steps you could have combined into one. So if you're dividing by 2 pi and we're using 3.14 for pi, you're just dividing by 6.28. 9.42 divided by 6.28 means our radius is 1.5. Now, the reason why using 3.14 makes this problem a little bit cleaner is now we don't have a number we have to round in the end. It isn't exact, but it's going to work for pre-algebra. Okay, now we know the radius, which means we also know the side measures of our square. So this is going to be 1.5, 1.5, 1.5, and 1.5. So hopefully we remember the area of a square formula. That's just length times width, or since length and width are the same, that's just side squared. So 1.5 times 1.5, or 1.5 squared, gives us the area of our square. And don't forget, anytime you deal with area, it's a squared unit. So, and this doesn't give us inches or feet or anything. It just says units. So it's going to be 2.25 units squared. Okay, so this takes a couple different steps to get to the answer, which some of your problems will do. So that's why I just wanted to take a look at 3 more here that I wrote out, upside down, in your book. Okay, this first one I wanted to address the 3 ways you can write your answer. They give us the radius of 5. They want us to find the circumference. Well, the radius of 5 times 2 gives us a diameter of 10. If it wants you to write your answer in terms of pi, you're just going to leave your answer as 10 pi inches. Notice we're not squaring this unit because we're not dealing with area anymore. That was just that specific problem. Or if I want to use the pi button, I'm going to end up with about 31.42 inches because I would do 10 times the pi button. If I want to use 3.14 as pi, 10 times 3.14 is 31.4. Now we can't keep a second decimal place there because 1 doesn't exist. You could put a 0 if you wanted to. So these are the 3 ways you can write your final answer. Your book will tell you which ones to use. The homework problems will tell you which ones to use. Okay. By the way, there are some homework problems that tell you to use 22/7. That is a common fraction version of pi. We're skipping those, but you can do those as enrichment or extra practice if you'd like. These are the 3 we're going to focus on. This one, we're asked to find the diameter when we know the circumference. So I'm going to use pi times diameter since that's what they give me, and it's one less step than if they gave me radius. To find diameter, I need to divide their circumference by pi. So whether you use the pi button or 3.14, notice they're very close. And don't forget to label. Diameter is just a 1 dimension, so it's just feet, not feet squared. Okay. And then here's the revolutions that we talked about. And this one has an extra step. We're going from 25 inches of diameter to a mile. So I looked it up. There's no shame in that. I went to Google and I said, how many inches are in a mile? 63,360 inches per mile. So that's going to come into play here towards the end of the problem. So in order for us to look at revolutions, we need to know what the measure of one revolution is. So one revolution is going to be equal to your circumference. So 25 times pi. And in this problem, I just did 3.14. 25 times 3.14 is 78.5 inches. You could use the pi button. You'll just have a little bit different with your decimal values here. So if your circumference is 78.5 inches for one revolution, and this is how many inches there are per mile, we can divide the entire mileage in inches by one revolution, which is the circumference. So divide, and we're going to round here. You get about 807.13. That means it's just over, so since we're looking for full revolutions, I rounded, about 807 full revolutions. That means this tire is going to rotate or spin just over 807 times, and that's going to cover this mile. Okay, now this is going to change depending on how big your tire is. The bigger your tire, the smaller your tire, the more or less revolutions you would have. And that wraps up our notes for this lesson. If you have any other questions, make sure you ask. Don't forget to label excuse me, all your problems. The only time you're going to square your units is if it asks for specifically an area application. Otherwise, all these measures are one-dimensional, so you just label with the unit.